Welcome. In this video, we're going to work with proofs with congruent triangles. We've done some proofs before, but let's start with a quick review of what a proof is. So in a proof, we explain step by step why something is true. Now, sometimes this might seem kind of obvious to you, but the point is we have to write down and explain everything so that someone else can follow our thoughts. In geometry, we typically write these in two-column proofs. So in the left, we'll write down the statements or what we know is true. Often, this is identifying equal parts. And then the right column is the reason. That can be definitions or theorems. It can be written in terms from the book or in your own words. When we start a proof, we're always told some information that's true. Those are called our givens. And we always start by writing those down so other people know where we started. And then we'll work to make conclusions based on the information in the given and the picture. We'll go step by step until eventually we get to what they're asking us to prove. Now, this particular section is about proofs with congruent triangles. So make sure you remember your information about how to show that triangles are congruent. We're going to use 4 key theorems. Triangles can be congruent by side, 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 angle, side, angle, or angle, angle, side. Take some time now to review these if you don't quite remember them. In this video, we're going to do 2 proofs together. And eventually you'll find out that a lot of our proofs use a similar pattern. So our first proof, we are given that AD equals DC. I often like to mark these things down on the picture. And also that AB is equal to BC. Remember, we said in a proof, our first step is to always write down that given information. So I have a table. We're going to fill in the information we're told. So the information, the equal parts, go in the left column. In our right column is the reason. And in this case, our reason is just given. We're told that is true. Now, often in the given, we'll find other vocab words that might allow us to make additional conclusions. But here, there's nothing else from the given. So let's go ahead and let's look at the picture. And from the picture, are there parts that we know must be equal? Not because they look equal, but because of something we've learned in geometry. Trace out those 2 triangles we're looking at. When I'm doing that, I notice that they overlap at that middle line, DB. DB, the segment, is a side of both triangles. DB is the same in the top triangle and the bottom triangle. So I'm going to go over to my table and I'm going to write down that I have another pair of equal sides. So DB equals DB. The reason for that is reflexive. Remember, reflexive means that something is equal to itself. Now look what I have marked. In order to prove triangles are congruent, you need 3 pairs of equal parts. Well, I have those 3 pairs because I started with 2 pairs of equal sides up there in my given, and I wrote down another pair of equal sides. That means I'm ready to say that those triangles are congruent. I now know that triangle ADB is congruent to triangle CDB. And again, look at what pairs I have equal. I have 3 pairs of equal sides. So that's side, side, side. Let's try a second one. In this problem, we are given that Kn bisects Jm and that angle K equals angle N. Again, go ahead and mark down any equal parts on your picture. So I marked that angle K and N were the same. Then we always start by writing down our givens. Now let's ask ourselves what that means. They told us that information for a reason. So why did they tell us that Kn bisects Jm? First, go back and review that definition. Bisect means to cut it into two equal parts. Okay, so Kn cuts Jm in two equal parts. So I'm going to mark the two equal parts. Okay, so if Jm is divided into two equal parts, I have two equal sides that I can now write down. In my proof, I'm going to write down that JL equals LM. For the reason, there's a couple different ways that you could write this. A lot of mathematicians in your book would simply write down definition of bisector. A lot of students prefer to write this in their own words and explain what it means. For example, you might write down a bisector cuts a segment in half, or to bisect creates two equal parts. Anything that tells me that you understand what bisect means and that that's kind of the key word. So let's look back at our picture and see if we have enough yet. I have I have a pair of equal angles and now a pair of equal sides. Okay, that's not enough to know that my triangles are congruent. What else does the picture tell me? Think back to one of the first types of angles we learned about, which were vertical angles. Vertical angles are made when two lines intersect, and those angles are equal. So I have another pair of equal angles. Let's go ahead and name them. Angle KLJ is equal to angle MLN. Make sure L was your vertex. In the right column, explain how you know this. We know this because they're vertical angles, and vertical angles are equal. Now we have enough marked that we know those triangles are congruent. Triangle KJL is congruent to triangle NML. Look at what I have marked equal. Well, I have two pairs of equal angles and a pair of equal sides that's not in the middle. So that's angle, angle, side. Just from our two examples, you might be noticing some patterns. So again, when you're writing proofs, start with your given information. Make a conclusion based on that given. What parts is it telling us are equal? Then use the picture. Common things that we'll use are vertical angles or sides or angles that completely overlap. Those are called reflexive. And if we're trying to prove triangles are congruent, you're always going to end with side, 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 angle, angle, side, or angle, side, angle. Proofs require some practice, but as you work through more of them, you'll catch on. I'm confident you can do this.